Okay, class, this is our first lesson on graphing rational functions. Again, what's a rational function? Anytime we have a polynomial divided by a polynomial. Again, rational meaning anything expressed as a fraction. So today is the first day of graphing rational functions. We saw a little bit of this earlier in parent functions. So that's what we're going to break into today, 1 divided by x. And again, translating that about the graph. Let's take a look. All right, so 1 divided by x. Now again, we talked before about we have two different types of asymptotes. We say, okay, where can't we have a domain for x? Well, domain is going to be all real numbers except x cannot equal 0. Because if we have 0 on the bottom, can't happen. Okay, can't divide by 0. So what we're going to do is we're going to draw a line, dashed line here at x equals 0. Okay, we can't have a domain there. So that's an asymptote, a vertical asymptote. Now we say, okay, as an end behavior, what happens as we go to infinity and negative infinity? So we're going in this direction and this direction. What happens here? Well, 1 divided by a big number goes to 0. Okay? And then likewise, 1 divided by a negative big number goes to 0 in the other direction. So anytime you have 1 divided by a big number, it's a very small number. So we're going to have another asymptote horizontally that goes, and this expresses end behavior. So I'm going to draw one like this. Now our graph, let's think about it. If we do an xy graph, let's do 1 divided by 1. Let's plug 1 in for x. We get 1. Okay. Let's plug 2 in for x. We get a half. 3 in for x, 1/3, 1/4, and so forth. And notice it starts to hug that line. It never crosses the line or touches the line, but it gets closer and closer and closer. Same thing here. Is 1 divided by a fraction, for instance, 1 divided by 1/2 is equal to 2. Okay? And then 1 divided by 1/4 is equal to 4. So then that number is going to grow as it gets closer to 0. So then we're going to have a curve that goes up this way. Okay? If we have the exact same thing, but on the negative side, okay? So this is on the positive side of 0, and this is on the negative side of 0. So very John Travolta-ish. Let's go through -1. And again, I'm not really concerned about the exact curve. We want a couple, maybe one key point per area. So one there at 1, 1, and at -1, -1. So maybe those two key points. Now, let's take a look here at this graph, function of x when 4 is divided by x. So how does this change the graph? Well, let's plug some certain numbers in. We have the same domain restrictions and same asymptotes, but notice, let's plug 1 in. 4 divided by 1 is 4. So we're going to have 1, 4. I'll do this in a different color. Okay. Let's plug 2 in. 4 divided by 2 is 2. So I'm just plugging in different numbers. Okay. I'm going to move this 1 divided by 1 out of the way just so we can get a better feel for the graph. Let's do 4 divided by 4, which is 1. And notice it's the same type of curve, but it's not as tight in the corner. So here, if we did 4 divided by 8, which is going to be a half. Okay. So it's going to be tight up here again, but it's going to go through, and it's going to be a little bit shallower, or not as tight as a curve. So you can imagine as this a value gets bigger, okay, it's not as tight. And again, what I want you to do is look for maybe 1 or 2 points in that region. So in this case, we can isolate, 1, 4, 2, 2. We can do 4, 1. Okay, highlight a couple points in area. And then likewise, we have the same thing down here. Let me go ahead and move this out of the way. We have -2, -2, -1, -4, -4, -1. And again, the same curve, but not as tight into the corner. So that number on top, this affects the curvature in that region, but notice the asymptotes stay the same. So that's just getting us started. So that's basically the parent graph and a little adjustment of the parent graph. Now let's look at it as translations go. remember we did parent functions, we could say, well, hk is our starting point, okay, hk. And if we do it to the negative first power, that's the same thing as writing it as a fraction. So we have h, or x minus h in the bottom. And again, you have hk as your starting point. So let's look at this example right here, okay? Our starting point is going to be 2, 3. So I'm going to go over 2, up 3, and that's my starting point. That's not actually on the graph, but what it does is it lets me know where my asymptotes are. And notice down below here, we can see our asymptotes are y is equal to k. That's our vertical displacement, and x is equal to h. That's a horizontal displacement. So I'm going to draw those two here. And in this case, we have y is equal to 3, and an x is equal to 2. Okay, and those are the asymptote lines. So let's go ahead and draw those in. So I'm going to draw a dashed line right here and a dashed line right here. Okay, and again, let's label them. Y is equal to 3, and x is equal to 2. So that's my vertical and horizontal asymptotes. Now let's talk about end behavior. Again, my A value is simply 1. So if this was my center, we're going to go over 1 and up 1. We know that's the tightness of the curve. So I'm just going to get 1 point in there, and I'm going to draw my general curve through there. And then 1 point away from the center on the negative side. And it's the exact same curve, just shifted over 2 times and up 3. And we get that by our starting point. Okay. Let's take a look at this more examples. So again, when I see this here, this is really x minus 0 on the bottom. So our starting point is 0, negative 5. So 0, negative 5 is right about here, and that's my starting point. So and again, I'm going to start with my asymptotes. I'm going to go horizontally across, and then straight up and down. And then we have a value of 8. So really what I'm going to do is to figure out what that is, I'm just going to plug in a random point. So again, at 0, let's plug in 2. Okay? 8 divided by 2 is 4. 4 minus 5 is negative 1. Okay? So we know we're going to have a point here at 2, negative 1. Whoops. Erase this here. A couple extra dots there. Okay? So if I plug in 2, 8 divided by 2 is 4. 4 minus 5 is negative 1. So I'm going to go over 2, negative 1. So there's 1 dot on the curve. And then let's just plug. I'm picking numbers that make sense. What are the factors of 8? 4. 4 goes into 8 2 times. 2 minus 5 is negative 3. So 4, negative 3. So right about here. Okay. So there is, oh, that's negative 2. Let's go down one more. Make it look symmetrical. Negative 3. So that's the curvature of our line. And again, we don't need many points, just a couple. And notice it's not as tight in the corner because that a factor of 8. And again, we're going to do the same thing. Now again, it's going to be symmetrical about the center point. So here I'm over 2 and then up 4 from the center. So let's do it in different color. So if I go, over 2 and up 4, I can go back 2 and then down 4, and there's a point. Here I go over 4 and up 2. I can go over 4 and then down 2, and there's a point. And then I could draw my curve through there. And again, these curves are just very generic. We're just trying to get a guesstimation of where they look. I'm just going to kind of get those out of the way. We don't really need them for the graph. Now that we've done it, I can erase it. And there we go there. Okay. If we're not able to couple, just plug in different points. Plug in negative 2. So we have negative 4 minus 5 is negative 9. And we can see that point over here as well. Okay. Right there. Okay. Next one. Okay. Again, start with the starting point, which is going to be 3, 2. So over 3, up 2 this time. And again, start with your asymptotes. Again, you want to be able to list these. So if I ask you to list them, you could simply say y is equal to 2 and x is equal to 3. Okay, and those are your domain and range restrictions. And again, we have a value 1, so we know we're 1 away here and here. Okay. So we're just going to draw a curve through those points. Nice and tight to the inside. And again, as you draw down to get closer and closer to those asymptotes. Okay. So that's how we see those. Now, let's look at this example. What I want to point out here is first, let's get our starting point, 3, 1. So we go over 3, up 1. And I want to show you one thing here. What's special about this problem is notice that we have a -2. So what's that mean? Instead of going up like this and down like this, that's positive, it's going to be flipped. So now it's going to go down and up on the left-hand side. Okay. So here we have a factor of 2. So again, I'm going to plug in points that make sense. Let's go ahead and plug in 5. Okay. And we'll kind of show what happens. 5 minus 3 is 2. -2 divided by 2 is -1. -1 plus 1 is 0. Okay. So we go over 5, and we're at 0. So it shows you we're on the bottom side of those asymptotes. So again, I'm just going to draw. I got 1 point, enough to get my curvature, and do that there. And then I can mirror the point about the center the same way over here. And now we're on the positive side on this side of the curve. Okay. So that's what we're looking for right there. Okay. Last one over here is just one of the same. Again, start with the starting point, -4, -2. So we go back 4, down 2, and there's our starting point. So we go down, and again, we have a factor of 3, so I'm going to plug in points that make sense. So I want, like I said, I want that 3 to make sense. So if I can get that to go to, a 3 as well, I'm going to plug in, -1. Because -1 plus 4 is 3. 3 divided by 3 is 1. 1 minus -2, or 1 minus 2 is -1. Okay, so we have the point -1, -1. So we have this point right here. Okay, so that's a good starting point, and then we can see the mirror image right here. So there's our kind of curvature of the line here, and then on the other side as well. Kind of 1 and 3 away, 1 and 3 away. All right, so again, we just want to get the asymptotes figured out, a general curve, maybe 1 or 2 points in the region to help us out. And again, notice to do that, I just kind of picked a point, so I have a guideline to go through. On our next lesson, we'll talk a little more specific about, those guidelines and how they go into overall thing. We have kind of a little analogy to go with that. I want you guys to try these 2 problems here. Again, don't need graph paper or anything. Just go ahead and sketch it out. Try to get a couple key points and just label them, and that should be good enough there. Okay.